To graph polynomials, you need to look at a couple of things. Okay, so first of all, if I have p of x is equals to, I don't know, 3x to the power of 5 minus 6x to the power of 2 minus 3x plus 5, okay, whatever. But the thing is, so what you need to look at when you graph a polynomial is the leading term. Leading term means the first term. It is also the term with the highest power, okay? So the one with the highest power. I don't really care about all the other powers. The highest power tells me the degree of the polynomial. Okay, it tells me the degree of polynomial. So for example, this is a fifth degree of polynomial. This is fifth degree polynomial. If the highest power is 4, it's fourth degree of polynomial, and so on. Now, this one is the leading coefficient. Okay, that's important because it's going to tell me the shape, the end behavior of the two ends of the polynomial, if you will. Okay, so for example, there's a couple of things you need to know. If I have px is equals to just a single x, okay, first of all, if you have p of x is equals to a constant, let's say, okay, 5, you are going to get a y is equals to, because p of x is y, right? You're going to get y equals to 5. It looks like that. Now, second equation you might get, okay, you might get a polynomial of x equals to, let's say, 2x minus 5. You have a linear equation where we're very happy with linear equations, hopefully. Okay, positive gradient, y-intercept is -5, so you're going to go something like that. You're crossing a -5, and this is the, I should write in blue. Okay, this is your graph for a first degree polynomial. Now let's go on to second degree polynomial. Again, something we're very familiar with. If I have x squared, okay, plus 2, for example. Okay, so that what this look like is x squared plus 2, happy face, going through 2. Okay, that is x squared plus 2. All right, now if it's negative x squared plus 2, so if this was a negative number, then it is basically negative x squared plus 2. Okay, so the leading coefficient is going to tell me whether it's going to curve up or curve down, and it tells me how the two ends are going to look like. Okay, so once we've done that, the general shape of it, okay, we are going to look at higher degrees. Right, now from the higher degrees, we might get p of x is equals to, we did down a second degree, we're going to look at a third degree polynomial, 6x minus 2 squared minus 2x plus 5, for example. That doesn't really matter. If you have a x to the power of 3, you're going to end up with something like that. Okay, the only thing I know for sure is y-intercept is at 5. You might get x of x is negative x cubed plus 6x squared minus 2x plus 5, same thing, but this time it's negative. If it's negative, what that means is we have a set of axes, same thing, but it's going to go the other way. Okay, the only thing I know for sure, this is 5 with other calculations. Then we're looking at a fourth degree polynomial, px equals to x to the power of 4 plus 6x minus 2, whatever, okay, squared, okay, whatever. Then basically what this does is it's going to go like, hey, we're going to go like this, okay, something like that. Okay, and obviously if it's negative, it's going to go down like this, okay, something like that. Okay, so generally as a summary of what polynomials look like, this is a little summary, right? In summary, okay, if we're talking about the highest degree here, if the degree of polynomial is an even number, so for example, what that means is that you might get, okay, you might get x to the power 4, or you might get x to the power 6, or you might get x to the power 8, whatever, as long as it is an even number, okay, as long as this is an even number, then I can safely say that the two ends are going to point to the same direction. Where am I? Okay, the cursor is here. I can say that the two ends of the graph will point in the same direction. Okay, in another word, what this means is if it is an even number, if this end is up, this end will also be up, and if this end is down, then this one is also down. Obviously, the ones that's down has a negative leading coefficient, and the ones that's pointing up has a positive coefficient. That is for a even number of power. Now, from here, you can probably guess what odd number of power is. So if the degree of polynomial is an odd number, okay, so what that means is, for example, you might get x to the power 3, you might get x1, just a single linear one, or you might get x to the power 5, whatever. As long as this is a odd number, okay, odd, and the other one was even, okay, then what happens is the graph is, the two ends will be pointing in opposite directions, okay? The two ends will point in opposite directions. Okay, what that means is in the graph, if on the left hand side it's going down, then on the right hand side it's going to go up. Or if the right hand side was going up, this side is going to go down. And again, of course, this one happens when the leading coefficient is positive, okay? And this happens when the leading coefficient is negative. I should do that over here too. So if leading coefficient is positive and leading coefficient is negative. And if the leading coefficient is 0, then that highest power is a 0. That means you don't have x to the power 3, you have x to the power 2, and so on. So we don't consider the leading coefficient being 0. Okay?